Okay, so if you see a question like this, and two things. The first thing I usually tell folks is, because we've been asked for area, and it's a circle that is involved, somewhere I need to get my area out of the way and remember that is pi r square, right? And the way I remember that it's r square, not pi d. So the only two is the circumference, which is c equal pi d, and r square. I know my area is always in like centimeter square or meter square. And to get a square, you need to square centimeter by centimeter. And that's why you've got that r square. Centimeter times centimeter will give me centimeter square. The same way you've learned that x times x is just x square. So that's how I remember area involve a square. Once I know the area of a full circle is pi r square, something tells me that there is a ratio that I need to put in front because I've not been asked to calculate the area of the full circle. So the first thing to watch here is they've asked me to look at the major arc. So the minor arc is the small one. So the major arc has got to be the big one there. Okay. So two ways. I could calculate the minor arc and calculate the full arc and just say, oh, it's going to be full circle, take away the minor arc. Or you remember the formula that we were using was to find the area of this arc. So area, we say, was angle theta, we call it, divided by 360. So it was a portion of 360 times pi r square. Okay, so that's the way we were taught, if we remember the formula. So if this is a non-calculator question, you'll be asked use pi equals 3.14, for example. Okay, that would be another thing. But for the major area, theta is this angle. So yeah, so I know a full circle is 360. Because I've already got 60 here, what's left? 300, right?
Mm-hmm.
And now I'm going to do 300 divided by 360, which probably everyone did, times 3.14. And what is r, the radius? 10, yeah, times 10 square.
I forgot it's a bigger angle.
So that's 100 times 3.14, which is 340. Okay, so next I'm going to use my fraction skills, divide by 10 both top and bottom. This is a multiple of 3. This is a multiple of 3. So I can change that to 10 over 12. Yeah?
Yep.
Or 5 over 6, because this is a multiple of 6 as well, and a multiple of 6. So it's up to you. So 5 over 6 should be at the end what I'm getting, times 314. Okay. And they've not told me, so 5 times 314 divided by 6, and that is 261. So this is where you're going to write 261.666, and I put dot, dot, dot. And now you're going to decide, they've not told me what to do, so I can just say this is 261.7 if I want to 1 decimal point. As long as I write that, 0.7. And because these were meter square, to 1 decimal place. So you've chosen to give me the answer with 1 decimal place, and you've noticed that the second decimal place was 6. That means I need to round up to a 7. That would be full mark if this is how this was given to me, right? If they told us use pi equals 3.14, obviously. If they didn't ask us to use pi is 3.14, you can decide you're going to use pi equals 3.14, or you can just use pi of your calculator, which give us this time 5 time shift to pi time 100 divided by 6. And this time I get 261.8 with 1 decimal place. Yeah? So if you decide not to use 3.14 but use pi, you would need to round to 261.8 with 1 decimal place and just put pi time 100. Yeah? So what I was saying earlier on is, imagine you can't remember this. The thing you need to ask yourself is, this is 60 degree, right? How many 60 degree can I fit into a circle? So there's another one there. There's another one there. There's another one there. And there's another one there. So how many 60 degree have I got in total? 1, 2, 3, 4, 5, 6. Yeah. And my major arc is 5/6 of the full circle. The major arc is 5/6 of the full circle. Yeah.
Mm-hmm.
And what is the area of the full circle? Remember, that is, unfortunately, you've got to know something. What's the area of a full circle? Pi r square. So my answer is just 5/6 of mean time pi r square. So without remembering the formula, theta over 360 time, etc., I just looked what I've been given, and I just noticed that if this is 1/6 of the full circle, this is 1, 2, 3, 4, 5, 6 of it left. And this is how you should be looking at solving a problem if you're given a question like this, without having to remember all the time. Because what's going to happen is, I can guarantee you, you're going to remember this for the exam or the test or whatever. In 5 years' time, I'll come and ask you a quick question like this. This won't come into play in your head. And you're going to try and see, how can I find out this area? You might remember pi r square. But it's better to have a way to get back an answer than trying to remember a formula all the time. Okay? So that's how you would answer this. So, lesson for today is the subject of a formula. What do they call the subject of a formula? So we're going to look at this and we're going to try and understand what they mean by the subject. Yeah? So if I show you C equal pi d, this is a formula that is used in math quite a lot, just to calculate the circumference of a circle. We just write it C equal pi d. Guess what? C is what they call the subject. And why do they call it the subject? Because we're working out C. We're working out C if we know, for example, the diameter of a circle. And that's why they call it the subject. So the method we use to solve equation is what we call the balancing method. So we've seen that before. And write down the opposite of the following. So whenever we've got an add, we take away. When we had a time, we were dividing. When it was taken away, the opposite was adding. I think I went through this before with you. And if it was dividing, It's just whenever we were solving equation, that's what we were doing, right? When you had like 2x plus 1 equal 5, I told you get rid of the 1 by taking away 1 on each side, then 2x equal 4, then get rid of the 2 by dividing by 2, both sides, and then you got your x equal 2. Okay? So now the question you might get asked during a test is make D the subject of the formula. Basically, try to work out what D is if you know the circumference. So how would you do that? By using the balancing method. Yeah, so basically, you've been asked to find the value of D if you know pi. Obviously, you know what pi is, right? And you know the circumference. How do we find D? By using the balancing method. What is annoying me next to D?
Pi.
Pi, right? And it's pi time D, yeah? When you
So
get
just
pi D, yeah.
you know, put it over to the other side.
Yeah. So basically
Take
you divide by pi both sides. Yeah, I heard someone saying to me, you divide. In order to get rid of pi by using that balancing method, because pi is timing D, you just divide both sides by pi. Yeah? So what you usually see is then the answer is just because pi divided by pi is 1 D, we write it as D, then your answer is C over pi equal D. And sometimes they just rewrite it the other way around, right? A equal B is the same as B equal A. Then that's you. You have changed, you have made the subject of the formula by just using this balancing method that you've used quite a lot when you were solving equations. Yeah? Is that quite simple?
Yeah.
Yeah. So basically now we can work out any diameter if someone give us the circumference, because we just divide the circumference by pi. Okay.
Yep.
So let's get some example. Here we've been told to change the subject of the formula to be y when you are given y plus x equals z. So how do we do that? What is annoying us next to y?
X.
I've got a plus x, yeah. I've got an add x. It's that whole thing, that operation here, which you call a sum. That whole sum, I need to get rid of. How do I get rid of it? I take away x from both sides. Yeah, that will go. The same way you were taking away numbers, you can take away a letter. And now you end up with y equals z minus x. And that's you've now changed the subject. The subject used to be z, is y plus x. Now you've made the subject as y equals z minus x. Okay?
Yeah.
And the same thing would happen on this side. I've got p equal q plus r. We can either swap it at the end or we can swap it at the start. Because you want, it's in math, you used to write from the left to the right. So you used to put the subject on the left. So then the first thing you would do, you would just swap them. So you would just say it's q plus r is p. It's the same thing as p equal q plus r. Now, because I want r to be the subject, I need to get rid of that q. Again, this is like an add-on, r plus q. So how do I get rid of a add q? The same way we did there with x. I just take it away from each side. Yep. And your answer should end up being r equal p minus q. And you've changed the subject from p equal q plus r to r equal p minus q. Yeah. So these are very simple one. Obviously, we start to crawl, walk before we're gonna run. So step by step, we're gonna get there. Okay. Easy examples. Now, remember what I said? we looked at add or take away. What's the opposite this time of, I've got a divide by A. What's the opposite of dividing?
Multiplying.
Multiplying. So in this example, they'll tell us to swap it first, right? So we're going to write B over A equal H instead of H equal B over A. So we'll go B over A equal H. You don't have to do that extra line, but they always like to write the subject on the left. What I do usually, I do that right at the end, but here they've decided to do it right from the start. So now the opposite of dividing by A is to multiply by A. Yeah. So time A both sides. So A, B divided by A, you can simplify A and A, you just get B. And on the other side, you'll get A times H. So now we've made we've made B the subject. Okay. And I think the way you've seen it before was, oh, if I've got a divide, I just move it on the other side and it become a time. It's because you time both sides by A to do that. Okay.
Yeah. Sorry, I'm just writing this down. Okay.
So for the next one, I've got a time. Okay, first of all, we'll swap it. So we do ST equal D. And I've got a S times T. What's the opposite of timing by T? Timing by S, divide by S. So divide by S both sides, and I get my final answer, T equal D divided by S. Okay. So the balancing method is a good method to employ, even to use, because it shows what we do in order to get rid of something, in order to move this on the other side. It might be a bit different for some of you who've learned the old way where moving on the other side becomes a divide, but it's just because you divide both sides that you end up by being able to do that. Okay. And it gives a better visual representation of what we do to some people who can't really see it. Okay, so now that we know how to get rid of an add or a takeaway or a divide or a time, they're going to make it a bit more complicated by adding something else into the mix, right? It was the same when you were solving equation. You started with x or 2x equal 5 and then divide by 2. This time we're just going to add. So here I've got 3g plus f equal y. So that's a g, right? Let's make sure that's a G. It looks like a 9 typed. So I want G to become the subject of this formula. I'm going to get rid of the plus F first by taking it away, both sides. I end up with 3G equal Y minus F. And my next stage is I need to get rid of that 3. It's a 3 time. So how do I get rid of a 3 time? Divide by 3. But this is the bit you need to be careful when you divide the other side. You divide the whole side by 3, right? Because we've divided that whole side by 3. So divide both sides by 3 and you end up with a big fraction, y minus f over 3. Okay? Or some people would argue you would still get the mark if you write it as g equal y over 3 minus f over 3. You would still get the mark, the same mark. Because you need to know that, you need to remember that you need to divide every term on that side. Or the easiest way is just to use a long fraction bar. Okay, so both give you the mark. For this one, we've got 4d minus 2w equal k. So I guess they're gonna, yeah, so 2 ways. You can either swap them or you can say, oh, I want 2w on the left side. What if I add 2w on both sides? These will go and you're gonna end up with 2w plus k equal 4d. Then you back to that same example that you've got on the left, get rid of the k, which give me 4d minus k, 2w equal 4d minus k, and then divide by 2 both sides, and then you end up with w equal 4d minus k over 2. Okay, so that would be sufficient as an answer. Again, if you had decided to do 4d over 2, this is where you remember I told you sometimes doing more might get you less, because
Yeah.
I've seen people going 4d over 2, right, minus k over 2. And they told me, how come I didn't get the full mark? There you go. Did you see what they've done now? They've put 4 over 2. What is 4 over 2? 2. At nat 5, you have to simplify a fraction as much as possible. And if you decide to put 4 over 2, remember that is an extra line that you're going to have to put 2d minus k over 2. And how many people would say, oh, but I did this, how did I not get the full mark? That's because there's a nat 5 marking instruction given to all the, the markers. A fraction needs to be fully simplified. And that is not fully simplified, then they don't allocate the full mark. Whereas here, no, you've put it as a complete fraction, it's enough. Okay. So it's just wee warnings that I give sometime, because it's so easily messed. Yeah.
Yep.
So there you go. So we've done a couple. Now I'm gonna let you think about these ones. So let's try and practice these. So some of them are going to be a bit challenging, but I'm gonna show you how to do them. Okay. So the first one, if I'm given x plus y equal 8, I read the question. So this is the bit that is the most important. We read the question, right? Make y the subject. Okay, cool. I've got y on the left side. Easy enough. I need to get rid of a x. To get rid of an x, I've got this invisible plus 1x. I need to take away that 1x or take away x. I'm going to take away x on each side. Yeah. And my answer should be y on its own equal, where did I put 8? Take away x. I'm looking at 8, writing 8. So y equal 8 minus x. Yeah. So the second one, I'm going to add x on each side. I will end up with 2y equal 2 plus x. And now I'm going to divide 2 plus x by a back fraction of 2. So you can either say this is y equal 2 plus x over 2. Yeah.
Mm-hmm.
Or you can do it the way where you're going to go is 2 over 2 plus x over 2, or half x plus 1. So if you decide to write 2 over 2, you need to make it a 1. In this example, they've made it y equal half x plus 1. That could be a question where they ask you, what is the gradient of this line and what is the y-intercept? Then you would need to write it like this to make it easier for you, because then you know this is m and this is c, right? Remember we used to write it as y equal mx plus c? This is where it would come handy. I think we've done some of them when we did the lines. The straight line, we did do some where you had to rewrite. Remember when we had the equation of a line like this? So we had to rearrange it. Okay.
Adrian, did you say y equals 2 plus x over 2 is a correct answer, yeah?
So to be honest, if they ask us, because this would be more of a, what is the equation of this? How could you write the equation of the line by giving the gradient and the y-intercept? Yeah, but 2 plus x over 2, you've made y as a subject. So to me, I would give the full mark for this. But then you've got to now know if they ask you for the gradient, that is x over 2, half x, and then the y-intercept 1. So that's why sometimes you see it written like that. But that should be enough. I've made the subject. That's what they've asked me to do, is to make y equal something over x, which is 2 plus x over 2. Yeah. But now, if they tell us to write it as in the form ax plus b, then you've got to find a, and then you've got to find b, because that's going to decide your mark. But to me, that answered the question. Okay. The next one, I've got y squared equal x. So balancing method, I've told you the opposite of adding is taken away. The opposite of dividing is timing. So the opposite of a square is this.
Square root.
Yeah, square root. So if I want to get rid of that square, I need to square root that side and square root that side. Because square root of y square is just y. Yeah? What number do you time by itself to give me y square? It's y. Y times y. Give me y. If you take the square root of it. And that's why if I square root that left side, I need to square root the right side as well. And the answer just becomes y equals square root of x. Yeah? So that was the only difficulty here, is to know that if you get y square, you need to square root it. If I had y cube, then you need to take the cube root. If they told you y cube equal x, then your answer would be y equal cube root, which is that cube root with a v3 there. Yeah? But they've asked us for the square, so we square root. Remember, we've got an invisible 2 there. Just mathematician being lazy, they're not going to put the 2. The same way they don't put a 1x if they don't have to. Okay. So for the next one, I need to get rid of the brackets first. Or you could divide by 4 each side, then you get x divided by 4, and then you take away 1. So x divided by 4 minus 1. So that would be another way of doing it. So the answer would be a quarter of x minus 1. So people usually would get rid of the brackets first. So expand, they call it. Expand, then make it as the subject. So you get extra mark for expanding and then making the subject. Okay. So the next one here, I've got a root. So what did we say? The opposite of basically square root and the square are both opposite. So I need to time both sides by, I need to square both sides basically to get rid of that root y. So you need to take 2x and you square it. And on the other side, you will get equal y. But because you do 2x and you square it, it's the same as 2 square times x square equal y. Remember we did indices at one point? So 2 square is 4 x square. So y equal 4x square would be your final answer. Okay. And for this one, I would get a third of x, because I'm going to divide by 3 both sides, plus k. Y equal a third of x plus k when you add k on both sides. Okay. So to make it easier for us, we don't need to expand, but if they ask us expand first, then do it, then you'll do it. Okay, guys, any questions? Yeah, so the subtlety is just to remember square root, you square it. If you've got a square, then you take the root. So for homework 1, you've got page 133, 136. So that's going to be your homework over the holidays, right?
No rest for us then, no.
No. I'm afraid it's through practice, or good practice, that you become good. You become better, I would say, because you guys are already good, I'm sure.
Oh. What are you laughing at, Kirsty?
Your Christmas miracle.
Chris, I know what I'm asking Santa for.
A brain.
Oh, that's harsh. So
Oh, I was talking about myself, not you, John.
So
oh my goodness.
15A, 15B. Let's have a look at the type of question we get, and we'll go through a couple of them just to give you. Yeah, so basically so these are the simple ones. We're gonna do this one. Or which one do you want to do? Pick between G, H, and I.
H and I look like an absolute barrel of
Yeah, I would
laughs.
say either
Right.
H or I.
Yeah,
Why don't you try
okay. So let's try H. Yeah. So we're gonna try H and see how we would go through this. So first of all, what are they asking me? Oh, make X the subject. So to make X the subject, this is how I'm gonna do this. Yeah. So first of all, I want X to be positive. It's on the left-hand side. You might argue that why don't you leave it where it is just now? Okay. I like everything to be positive though. It makes life so easier. So to get this X positive, I need to add plus PQRX on both sides. So if I do that, I add both sides plus PQRX, you're gonna get X positive. Guys, I see so many people making silly mistake with negative numbers that it's not that I freak out when I see negative, but I would rather make my life easier. Then what I'm ended up with is M plus PQRX, yeah? Equal 1. Do you agree? We've just got rid of that PQRX and we've added, because we've added it on both sides. Is that easier now?
Much.
So,
I would say so.
yeah, so the next thing I need to get rid of is that M. This is an add M, so I need to take it away. So take away M on both sides.
1 minus M? Oh, it was 1 over M? No, it's
So
just 1
1 minus M, so you just take that away from it. So now that gives me
minus M.
PQRX equal 1 minus M. Remember, you treat M as if it was a number. So if you had here 1 and here you had take away 5, you would say 1 minus 5. Because it's a letter, it's even easier. You just write 1 minus M. That's what you've done. You've taken that away. The same way you've done M minus M to make 0, here you get 1 minus M. Yeah? And now, to get rid of PQR, which is all timings, what do we do with timing by PQR? We divide both sides by PQR. And that's us. That's our answer. that becomes 1. Remember when we used to simplify, that's a 1x equal 1 minus m divided by PQR. So we've made x the subject. Okay. So we've made it the subject. So if you had decided you wanted to keep the negative on that side, then you would get a m minus 1, but then you would need to divide by minus PQR both sides, and m minus 1 divided by minus PQR, then you need to remove the negative at the bottom. That means you change the sign, both sign of 1 and m at the top. Whereas I didn't need to do that because I'm dealing with positive numbers only. So it remove one extra layer of difficulty by making it positive where I want to. Okay? Okay?
Yep.
So that's how I would do it. Now, remember we looked at fractional with divisions and stuff, and you were going like, whoa. So unfortunately, when you make X a subject, these are very common question that comes. Okay, so what we're gonna do, we're gonna try G this time. Okay, let's try G. How are we gonna solve this, for example? We've been told to make X the subject. So the first thing I do, the first thing we do is we get rid of the 5. Okay.
Mm-hmm.
So to get rid of the 5, I would go y minus 5 because I'm taking away 5 on both sides. So I get y minus 5. So this is G, right? Let's write it there. Equal 2x plus 1 divided by 2, yeah?
Yep.
So the same way I don't like negative numbers, there is another class of people that hate seeing fractions. So we need to get rid of that divide by 2. What's the opposite of dividing by 2? Multiplying by 2. So by multiplying both sides by 2, that means we're going to get rid of that divide by 2. And then we end up with 2 times, so you open the bracket, y minus 5, because we're timing that whole side, equal 2x plus 1. So now we got rid of the fraction, yeah? And things are looking a bit easier. Because remember, what I'm trying to do is get x on its own. So how do I get rid of a plus 1? Take it away. So I'm going to take away both sides. So this is the bit where now you get, we can just say 2y, because I've just done, I'm getting rid of the fraction, the brackets, minus 10 minus 1, because I'm just taking away 1, equal to x. Yeah?
Yep.
So now I'm going to group the likes. That is 2y minus 11, yeah? Minus 10 minus 1 is minus 11. Equal to x. And my last stage, I want x on its own. Because I'm timing by 2, what do I need to do? Both sides. Divide by 2, yeah. And that's you've got your answer. 2 over 2 is 1. 1x is just x. Equal 2y minus 11 over 2. So we can leave it like that. Or you can say 2y over 2, which is y, minus 11 over 2. So you can rewrite that as y minus 11 over 2. Yeah. So I'll check some marking instructions on past papers just to make sure that this is still acceptable. I'll check that because there had been in the past some past paper with this. Okay, so that's us. We've got our answer there. X is the subject now. So sometimes instead of having numbers, they only deal with letters. So let's do this one. E. They've told us to make the subject the letter in brackets. So I've got V minus U divided by A equal T. First thing first, I need to get rid of that fraction. So I need to time by A both sides. Yeah?
Yep.
That will get rid of my fraction, or the divide by A. So I get AT. So you can write it like that, AT equal V minus U. And now I want to get rid of the takeaway U. The opposite of taking away is adding. So I just add plus U both sides, and that's U, you've got your answer. Then that means V equal, so you can write it as U plus 80. Yeah?
Mhm.
And that is because my background is science teacher, that is an important science formula. So in physics, basically the velocity is, or the speed is the initial velocity plus the acceleration time the time. Okay, and that's what it is. So they're going to use all these as, you know, science formulas that they want you to rewrite. So if I'm given the time and the acceleration and the initial speed, they might ask me what is the, you know, the speed at the moment, what is V? Then I just substitute this with V. And when they gave me to start with what the time was. So it's current speed minus initial speed divided by acceleration. That gives you the time. Okay. And you've got other ones there. I is a current divided of, it's the voltage divided by the resistance, or the force is divided by the acceleration or gravity, sometimes they use, is M. The height is an energy. So all these are used in science quite a lot. So this is where you apply math into science, for example. Okay. And I'll let you work this problem. And we can take a break. And when we come back, we'll have a look at these. So it's a bit like one of the exercises we've just done. Okay.
Okay.
And we can be back in 10 minutes. I'm going to pause the recording. Okay, yes, for these kind of questions, so basically what I'm looking for is make G the subject. Anything around G, I'm going to try to get rid of. And if I'm timing, first thing first, I'm going to divide by what I'm timing with, and that gives me the answer straight away. So M divided by M is 1, so that means G equal F divided by M. My writing starts to get really bad. It's just that I've changed my desk and need to get used to this one. For the second one, we're going to divide not only by m, but by h as well. So we're going to divide by m and h. So divide by mh to get rid of it. So that means it's E divided by mh is my answer. So G equal E divided by mh. So you basically, you see what we're doing, right? This time I've got a divide by 2 to start with. So I'm going to multiply by 2 both sides. That means I've got mg square equal 2w. Okay. Then I'm going to divide by m to get rid of that m. That means these two simplified. And what we said was the opposite of squaring is taking the root. So G is just square root of 2w divided by m. So I should do my square root a bit better. It's just this part, okay? And that's your answer. So the only difficulty was to make sure that when you square it, remember, you can see it's going all the way down. So don't just square the 2w, but it's the 2w divided by m that we square. Okay, so we've done 3 typical type examples that you would see for formulas being used by science. So this time they've just told us we're going to do the same work that we've done, but with formulas including squared and square roots. So we've already done it, to be honest. So we just said square root opposite is squaring, squaring opposite is square root. So that's what we've just done. We're ahead of the game now. Make the speed s the subject. So first of all, I'm going to divide by k. Both sides divide by k, so you get s squared equal f over k. Then we take the square root, and your final answer is s is f divided by k. Square root of f divided by k. Okay. I think that's the tiny bit of difficulty when it comes to changing the subject. People are not too used to square roots. Now, in this example, we've got the thickness of a rope T in centimeter to lift a mass, not a weight, a mass, W tons, can be worked out by the formula below. Okay? Make W the subject. So I want W on its own. So first of all, we're going to get rid of that divide by 9, the fraction, by timing by 9. So then we get 4 root W equal 90. Then we're going to divide by 4. Root W equal 90 over 4. And the opposite of square root, is to square the number. So then that means W is 90 over 4. You put the brackets square. Okay. And that should be enough. No calculation needed. Because someone might ask me, do you need to do 9 square, which is 81 divided by 4 square, 36? No, you can leave it like that. That'd be perfect. So another thing, sometimes you see formula below is used to change. So if you've got something given like Fahrenheit, degrees, and degree C. So there's a formula here. So you would like to know how much degree C is going to be if someone gives you the value in Fahrenheit. So that means you need to make the subject C. So first of all, we take away 32. Oh, they change, basically this time they're just timing by 5 to get rid of the fraction. So you could do it that way. It just means you get 9c plus 160 equal 5f. Then you take away 160, and after that, you so they factorize that, and then you divide by 9. Okay. So have you noticed they added a small layer of difficulty here by forcing you to factorize. You don't have to. If you didn't time by 5 to start with, we could have just said, from here, I'm going to take away 32 both sides, and then you would get your f minus 32. That means you don't have to worry about the fraction. Okay. So then that means you would have 9 over 5c equal f minus 32, like this. That would be another way of doing it. And now to get rid of the 5, you need to time by 5. So at this time, you would put the brackets in, and then you would time by 5. So that means you don't need to do too much of the factorizing part. So you time by 5 both sides, then you get 9c equal 5 times f minus 32. And then your last stage is to divide by 9. So I would argue that that's probably the easiest way of doing this, rather than trying to get rid of the fraction at the start. So you've got two ways of doing it. Because by doing it this way, you need to time 5 by 32, which is 160, and then you need to factorize. Put 5 as the highest common factor. So two ways. Now, this is number 2. Let's see what kind of. So we've got 15D, 2, 3, and 4, and it's page 142. Okay, so let's try a couple of them. So you pick.
Oh, C?
C?
Yeah.
Did you say C? Yeah. Yeah, C is a tricky one.
Yeah.
Yeah, C could be a tricky one. So let's try C. So they've told us to make X the subject. Okay. So from the book, this is not written exactly the way I want it to, but to me, this is 3 times root X plus 1 divided by 4, and not cube root, because I've got a 2 times root X here. Okay, so if I was to write it properly, this is how I would have written this. The 3 should be right up to that same level at the base of the root here. Because you can see how a 3 put a bit too high up can confuse you and you think this is cube root. But no, it's 3 root X plus 1 divided by 4. So the first thing is I need to get rid of the divide by 4. To do that, I time by 4 both sides, yeah? So if I time by 4, this fraction, these two will go, and I get 4y, yeah? So C, let's do C here. So I get my 4y, because I've timed by 4, equal 3
times by
times by root x plus 1. Okay. So I just got rid of the 4 basically. Now I need to get rid of the 3. If it's a time, how do we get rid of it? Divide by 3. So now I've got root of x plus 1 equal 4 over 3y. Yeah? And what did we say about what is the opposite of squaring the square root? The opposite of it is to get rid of it, we need to square everything, yeah? So now you end up with x plus 1 because we've squared a square root. That gives us the number itself. It's just 4 over 3 y square. And now I want x on its own. How do I get rid of a plus 1? I just take away 1, both sides. And my answer is x equal, so you can leave it like that, 4/3 of y square, this is a bracket, minus 1. That's it. That's us. So it looked quite complicated to start with, but the only complication was to remember to get rid of a square root, you just need to square both sides, and that gets rid of the square root. Okay, and I've got my square there. This is a square. And the square applies to the 4, to the 3, to the y. And that's why sometimes you see it, people will write it as 16 over 9. You still get the same mark, y square minus 1. So you would still get the same mark because that is 4 square and that is 3 square. Okay. So again, this is 2 times, this is 5 times root x. And what I was saying, for if you get a cube, you just need to cube root. So that's even easier because you need to take the cube root of y here, cube root of y equal x plus 2. And now you want to make x the subject, that means you take away 2 from both sides. Yeah? That means x is cube root of y minus 2. And again, when you write it, make sure the square root stops on the y, or the cube root stop just for the y. And then next to it is minus 2. You take away 2 from both sides. Okay. So we've done 2 of them. One with the cube, one with the square roots. So let's have a look at the next exercise. Yeah, it's still the same because it's just A, B, C, D, E, F, G, H, J, K. Okay, so let's try something a bit more complicated. We can try this one, J. Let's say you've got x as a fraction there. Okay, so what you could do is you can make this a 1 by timing both sides with root x plus 4, right? So if I time by root x plus 4, both sides. Then that will become a 1. But on the other side, I'm going to get y times root x plus 4, right? Do you agree? Equal 3, because I've made that side a 1. Because these two will cancel each other. So basically, we time both sides by root x plus 4. And once we've got that, now we need to get rid of the y. So because it's a time y, we're going to divide both sides by y. Yeah. So then I get root x plus 4 equal 3 over y. And now, how do we get rid of a square root? We just square the numbers.
Number.
Then that means x plus 4 equal 3 over y with brackets square. So it doesn't matter, the letter could be as a denominator. And now take away 4 on each side. I will get rid of that 4, but you need to take away 4 as well there. And that's you. X is 3 over y squared minus 4. And that looked quite complicated to start with, but we just got rid of the denominator in the fraction there by timing by root x plus 4. So you need to do the same here, timing by root x and timing by root x minus 1. And all these should be very similar. Okay. So that was problem 2. Problem 3. So we can try C, for example. So the first thing first, I want K to be the subject. So I'm going to move G on the other side. I get W plus G equal 3 over K squared. So I've just moved the G. Now, how do I get rid of that divide by K squared? You need to time by K squared both sides. And remember, because you time the whole thing, you need to put brackets. Then you end up with K squared time W plus G equal 3, because K squared divided by K squared is 1. Now I'm going to divide by W plus G both sides. So we need to divide by W plus G to get K squared on its own there. Yeah?
Yep.
And now, how do I get rid of a square?
Square root.
Square root both sides, yeah. That becomes K equal, again, square root right up from the top to the bottom, 3 divided by W plus G. That's us, we've changed the subject. And we got K as the subject, which was the question there. Make K the subject. So technique, and yeah, you will see a lot of square roots and stuff, so that's why you need to get used to those. So this is 1 divided by BH. That's the square root there. So all these should be in your book. better written than this. This is square root of t in the fraction value. Okay. So let's see the last part of the changing the subject, understanding formulae. So in real life, we often want to see what effect change the value of one of the variable, what effect changing the value of one has on the subject. So what happened to the circumference if we double the diameter? Yeah, so these are the type of question you may be asked. What happened to C if you double D? Because D is going to be 2D, you're just going to double the circumference. Yeah, C equal pi. So it's like you can put 2 outside and the circumference being pi D. By doubling the diameter, you double the circumference. It's just direct proportion, basically. So now, the area of a circle is given by this formula, pi r square. So what happened this time if we double the radius? Okay, so let's see what effect it's going to have. So, because we've got 2r now, r becomes 2r, so you get pi is 2r square. And now what's happening? 2 square is 4, and the original area was pi r square. So if you double the radius, you time by 4 the area. Okay? It's to do with that square. And when it comes to a volume, because it's a cube, if you just double one of the length of your cube, you do 2 times 2 times 2, your volume goes up by 8. Okay, so we can look at that. So let's go back to this exercise that we had when we were told the thickness of a rope to lift a weight can be worked out by this formula. Now, we've been told here, if we increase W by a factor of 100, what effect does this have on the thickness of the rope? So what I'm going to do, I'm going to put W, but I'm going to make it 100 W. So the problem is, if you make it 100 W, what is root of 100? What do you need to time by itself to give you 100? 10, yeah. Because now the 10, you can write it outside. The original thickness of the rope has been multiplied by 10. So you need, so if you increase the weight by 100, you need to make the rope 10 times its size, basically, if it was to support that kind of weight, based on this formula. So let's have a look at some examples. So it's the effect of changing a number into a formula. So let's do a couple of practice. Okay, page 143, 15D, 6, 7, and 8. Are we good?
2 seconds. 1, 4. Yeah.
So let's see, first of all. So these are like solving problems. So problem solving type. We've been told that the gravitational force of attraction, that's what we call F, as a force, so it's usually in Newton. Between two bodies is given by F is G, M, so the mass of one of the body times the mass of the second body, divided by D, the distance between them two square. And G is what they call the universal gravitational constant. M and M masses, two bodies, and D the distance. So we've been told to do first, make D the subject. Okay, so how do we do that? We time by D square both sides to bring D here. So we time by D square. Then that means we've got FD square equal G times capital M times small m, the mass of the two bodies. Now, to make it the subject, it needs to be on its own. So we need to divide by F both sides first. Yeah?
Mm-hmm.
So that means D square is GMM divided by F. And then the opposite of squaring, we said, was taking the square root. Yeah, that will get rid of that square. D is just square root of GMM divided by F. So that would be worth like a couple of marks for that first question.
This kind of question, like a standard.
Yeah, so if
Question, not
it's a real life scenario, basically. You've been given a formula, which is used in science quite a lot. They just ask you to make the subject, D being the subject.
So that's what I'm saying. So see how you were saying the unit thing test that we done, that kind of is a kind of grade C kind of leveler.
Yeah.
Is that something that if you got this question correct, that would be like a grade A?
Yeah.
Kind of.
So these are the top grades, Mark. Whenever you're going to see a star with goggles like this, it involve a lot of thinking. Yeah. So those are the ones that where you need to do a bit of work in. Yeah. These are the grade A. So if the distance between the two bodies is doubled, so let's see what they're telling us. Remember, we were looking at doubling something. What happened? What is the effect on the force of attraction? Okay, so if we double the distance. Okay, so that's question B. So they've told us to double the distance. So let's say we've got F. Now you go back to the original one, F equal GMM. Okay, divided by, now instead of D, we're going to make it a 2Ds, right? D will become 2D, and we're going to see what's going to happen. We've doubled if the distance, yeah. Remember, you've got D became in 2D square, right?
Mm-hmm.
But we've learned that when you've got two factors like that, two numbers multiplying, and you square them, it's the same as squaring each of them, right? So you get GMM divided by 4, because it's 2 squared, D squared. Okay? And that is same as writing a quarter of GMM divided by D squared. I'm trying to basically get back into this F here and see what we've done is we've doubled D doubling D basically divided the force of attraction by 4. That was the original force of attraction. That was original force of attraction. Yeah, that's what we were trying to aim at and see what doubling D has done to the force of attraction. Original force, basically. So your answer to B would be force has been divided by 4. Yeah, divided by 4. If you were to answer the second question. Okay. So let's think about this physically. If you've got 2 planets, for example, okay, the further apart those 2 planets are, the less force of attraction you get between them 2. And if you speak to people looking at planets and how they, you know, go around each other, so the closer you have 2 bodies, the stronger the force of attraction between the 2 bodies will be. Okay. And that's why they would say to you, for example, a black hole in the universe has got so much like weight that it would attract anything going around to it. So if there was a massive black hole close to our, you know, universe, it would attract all the planets and we would just get sucked into them. Okay, so that's the theory behind it, but they use these force of attractions. Okay. So let's have a look. Yeah, so this would be then further question asked if you were doing like Nat 5 physics and stuff like that. So they would ask you more question after that. And that's why you've got another type of problem here where they're looking at gas molecules. You could try this one. And this is applied to distance when you brake, just before braking. Braking distance, basically. So we could try that. We'll go through them. So there's quite a few questions. Okay. So if you get stuck, don't spend too long because we'll go through them. And then after that, I just put some past paper type question. You can see they're not too difficult. Change the subject of the formula to H. So you would get rid of the fraction first, time by 2 both sides, and then add T. So you can see this could be like a couple of marks. Change the subject of the formula. So typical past paper questions are all coming that way. Change the subject to M. Again, they like to put these fractions, so get rid of them. Time by 3 both sides. And so on and so forth. So most of them would either have a fraction or a square number, or both a square and a fraction. Or sometimes it could be very simple, a 1 mark. Okay.
Yep.
So there's quite a few on that paper anyway. And